Example 16 wants us to simplify trigonometric equations. So we have to think about what our identities are, and we can want to interchange them to make the simplest possible answer that we can. So we're normally looking to see if we can call things in terms of one trig function, maybe two at the most, and quite possibly even just maybe a single number. That's very possible. So we look at A says simplify the sine of A times the quantity, the cotangent of A, plus the tangent of A. Okay, so now what we're going to do is we are going to attempt to simplify this any way that we can. So I'm just going to pick away, and here's the thing. It does not matter what you do. What matters is that you can do something legally. Switch something that it is legal to switch. And if you can do that, then you will not be wrong. Okay, so multiple different ways, whatever way you think, give it a shot, and just keep working with it as much as you can. If you get stuck, go back, try another way. So what I'm going to choose to do is I'm going to choose to simplify this at first by turning these two terms into one by adding them together. Well, cotangent and tangent, we don't know about what their sum is together. So one thing that I'm going to think to do is, and the last thing, or one thing you can always think to do, is convert everything to sine and cosine. So I'm going to leave the sine alone, and I'm going to convert the cotangent to the cosine of A over the sine of A. And I'm going to convert my tangent to the sine of A over the cosine of A. So it looks like I made this more complicated, but what I'm going to do now is I'm going to convert these two fractions together. I'm going to add them together. So we want to think about how we add fractions. So adding fractions works in the following way. We take the top left fraction, or the first fraction's numerator, we multiply by the denominator, so we get cosine times cosine, it makes cosine squared. We then take the term in the middle, which is a plus. So if we were subtracting, we would put a minus there. By the denominator of the first one times the numerator of the second. So we multiply up. So this becomes sine squared. And then we're going to divide by their denominators multiplied together. So this would be sine of A, cosine of A. Now, it may still even look like I've made this much more complicated, but what I have done, in a sense, is I've set myself up for success because there are a couple of things that I see that I can do. Firstly, I see that I am multiplying by a sine and dividing by a sine. So these together are going to cancel each other. Now, a second thing that I see here is this part, cosine squared plus sine squared. If you remember from before, there's this nice fun rule that says that cosine squared plus sine squared always equals 1. I can replace that entire numerator with the number 1, because no matter what, cosine squared plus sine squared always equals 1. So what I'm going to get here is going to be this whole thing up here makes 1. And I'm going to be dividing that by regular old cosine. And what do we remember about 1 over cosine? That is the same thing as secant. So it's a fair amount of work, but all of these parts can be replaced with something else. A sine and cosine cannot be replaced, sorry. But the other ones can be replaced. And we can also replace more complex looking parts, like cosine squared plus sine squared, but with 1. And then we can replace things with other identities. So there's a freedom to what we can do as long as we apply appropriate mathematics. So what we had to know how to do in this case was we had to know how to add some fractions, which is the same no matter whatever you do. Just go through the process to add the fractions. And then anything that comes up that you can simplify, go ahead and simplify it. So I noticed a multiplication and division, was able to do that just fine. So this is excellent. This is an excellent thing to do. So let's move on to the second one. So our second problem listed said simplify 1 minus the sine squared of a times 1 plus the tangent squared of a. So could think to do several things in this case. We could multiply this all out. It would make a very long term. Or we could start simplifying or replacing parts here and there. So what I want to do is draw your attention back to our Pythagorean identities. So I'm just going to draw you back. So we had 3 Pythagorean identities, and those were cosine squared of a plus sine squared of a, or theta, equals 1. We also had um, 1 plus the tangent squared of a equals secant squared. And our last one was cotangent squared of a plus 1 equals cosecant squared of a. Now you're not going to use all of these every time, but sometimes they're directly available, which one thing that's awesome about this problem, so if we look, 1 plus tangent squared is right there. So we're going to be able to replace that very easily. But sometimes you have to be able to think a little bit outside of the box and think, hey, how can I make something work for me? Now, all of these formulas are true all the time. So if we do something legal to them, they're still always true. So if I look here, I see this 1 and this minus sine squared. Now, I don't see that in any of my identities, but I can make it if I think about what I have, right? So 1 and sine squared go together with something. So maybe it should occur to me to try and see if I can make that work. Well, how would I make 1 minus sine squared out of this? Well, if I have a 1 over here, what if I subtracted sine squared from it? So if I subtracted sine squared from that, I would have to do it from the other side too in order to make my identity still true. So if I take away sine squared from this side here, I'm going to be left with cosine squared. Now if I take my sine squared away from the 1, I'm going to have 1 minus sine squared. And if you see, I've just created, in fact, another identity that is always true. Because cosine squared plus sine squared always equals 1, I can subtract sine squared from both sides because that is legal, and I get this equation. So this is something that I'm going to use to help solve my problem. 1 minus sine squared is always the same thing as cosine squared. Always. It's always the same thing. Now, I also know that 1 plus tangent squared is always equal to secant squared. Always. So this is allowed to be switched. The other identity I do not need, but it's always good to look and make sure and see what else I can do. So far I've done this. Now, what's excellent about this problem is that cosine and secant work together and they match very well. The cosine squared can stay here. Secant squared is the same thing as 1 over the cosine squared of a. We'll look at what we have. We are multiplying by a cosine and dividing by a cosine, or multiplying by a cosine squared and dividing by a cosine squared at the same time. When they cancel, they are just left with the number 1. This entire identity up here, or this entire expression up here, simplifies to the number 1. It always is equal to 1, no matter what angle you plug in. And we've shown that because all we've done is legal substitution. We've changed the way things look, but we have not changed the value that it takes at any time. So you always want to look and see, how can I make these parts go together? Because if we can make these parts go together, then we can actually simplify them to make very simple statements. You can't always do it with every trig expression. It does not work that way. But some of them you can simplify to make easier for yourself. And you always want to use your identities to do that.